With the introduction of these advanced humanoids, the factory has reached unprecedented levels of efficiency. Project Cyborg aimed to replicate human locomotion, but as you can see, stability remained a significant challenge for the machines of this era.
Hey everyone, and welcome to this explainer. Today, we're diving into something that is happening so quietly, right under our noses, but it represents an absolutely massive technological leap. It's the kind of reality that feels like it really belongs in the distant future. But well, that future has already become our present. Get ready, because the rise of humanoid robots has already begun.
I want you to just pause and picture this for a second. Somewhere on a factory floor, literally right now, there is a machine. It has 2 legs, 2 arms, 5-fingered hands, and it's picking up a part. It's turning that part over and placing it exactly where it needs to go. Just let that sink in. We aren't talking about some specialized robotic arm bolted to a table. We're talking about a free-moving machine navigating space and working flawlessly with human-like hands.
I mean, we've all kind of shared this exact same assumption, right? That humanoid robots are just science fiction, or maybe they're clumsy, slow novelties kept in advanced research labs. But actually, scratch that. That era is completely over. These machines aren't just a theoretical concept anymore. Today, they are secretly working real shifts on actual production lines in real factories. All right, let's look at Section 1, the impossible problem. Why walking on 2 legs is so hard. You see, for decades, engineers have chased this dream, and for decades, they basically hit an absolute brick wall. If you look at early attempts throughout the 20th century, they involved building these incredibly rigid, wire-driven machines, and the result? They could barely take a single step without completely toppling over. Every single attempt taught engineers the exact same harsh lesson. Gravity is unforgiving, and standing up is incredibly difficult. Just think about these specific physical hurdles for a second. Walking, gripping, balancing, adapting. For the very first time in history, machines are being built not just to calculate numbers or communicate data, but to physically move through the world exactly the way we do. Now, we take these actions totally for granted every time we roll out of bed or pick up a coffee cup. But for a machine, these aren't just simple movements. They are monumental math problems, calculating shifting weight, compensating for friction, and maintaining spatial awareness in real time. It's an almost insurmountable physical hurdle.
Which really brings us to the ultimate irony of modern technology. We have successfully figured out how to fly rockets into space. We're figuring out how to let AI drive our autonomous cars around our cities. But walking on 2 legs? According to the engineers who studied this stuff, it's actually one of the hardest problems in all of robotics. Seriously, it is literally harder to build a machine that can walk across a room without falling over than it is to launch a rocket into orbit. Crazy, right?
Which brings us to Section 2. The invisible revolution. What changed? So, what actually changed? If walking is literally harder than rocket science, and robots were just falling over for the last 100 years, ask yourself, how did we get here? How did we get to a place where machines that once collapsed after a few steps are suddenly, flawlessly, working complex shifts in real factories? Well, the answer really isn't what you might expect. The big turning point didn't actually come from the physical realm. It wasn't about building better motors, and it definitely wasn't about forging stronger, lighter metal. The massive twist here is that the solution was an invisible software revolution powered by modern AI. It wasn't a physical hardware upgrade at all. It was a complete paradigm shift in how machines compute movement. Let's define this clearly, because this is the invisible leap that changes absolutely everything. Instead of engineers trying to meticulously hard code every rigid joint movement, like writing a physical instruction just for a motor to take 1 step, these machines are now using AI and neural networks to actually learn movements. Through reinforcement learning and millions of virtual simulations, they learn to adapt to the physical space around them. It's a lot like how a human toddler learns to balance through trial and error. They aren't just executing rigid code anymore. They are dynamically adapting to the physical world. And that brings us to Section 3. A stranger story begins. The future of the factory floor. Think about this. If we have suddenly solved the impossible problem of bipedal movement, we are standing on the precipice of a very different reality for our daily lives. The source material leaves us with this exact, honestly kind of eerie thought. It notes that this invisible revolution in movement is only the beginning of, quote, a much stranger story. The monumental hurdle of conquering gravity and balance. That was just chapter 1. So, I want to leave you with one lingering, provocative thought today. What happens next? Now that robots have learned to walk. If the absolute hardest problem in robotics has been quietly solved by an invisible AI revolution, and these machines are already operating on factory floors today, where does this reality go from here? Thank you so much for joining me for this explainer. Keep questioning, keep learning, and absolutely keep your eyes wide open to the future, because it's already here.
There's the wobble at 70% capacity. And immediate correction. Efficiency improved by 12%.
Welcome to this explainer. If you've spent literally any time online recently, you've undoubtedly seen the unbelievable footage of robots doing things we all thought were, decades away. We are going to decode this sudden leap in humanoid robot capabilities, and specifically, we're zooming in on the massive breakthrough in exactly how AI teaches them to move. Right off the bat, it's the exact question on everyone's mind. After watching all these viral clips, how did humanoid robots suddenly get so good? I mean, for years, progress felt incredibly slow, right? Clunky, awkward. Then, seemingly overnight, these machines became incredibly agile and reactive. And the secret to all of this? It lies in a complete, ground-up reimagining of how they get their instructions. Okay, let's dive into this. To truly appreciate what a huge breakthrough this is, we kind of have to look at the limitations of the past. The old way was programming by hand. Engineers literally had to sit down and manually write code for every single motion. Just imagine trying to explicitly program every joint angle, every tiny shift in weight, just to get a robot to take a single step. And if the robot encountered an unexpected pebble or a slightly uneven surface, well, it couldn't adapt. It would just fall over and fail. It was an incredibly tedious and ultimately a really limited process. But thankfully, that restrictive era of manual coding is totally over. We've entered a massive paradigm shift. AI learning from experience. This right here is the core of how AI teaches robot movement today. Instead of relying on these rigid, inflexible lines of code dictating exactly what to do, engineers are now utilizing artificial intelligence systems that are trained on massive amounts of real-world movement data. They're finally giving robots the data they actually need to literally figure out movement on their own. This kind of training fundamentally teaches robots to perceive their surroundings and react in literal fractions of a second. The source material describes it beautifully, saying it's happening the exact same way a human instinctively catches a falling glass. And it's a perfect analogy, isn't it? You don't consciously calculate gravity and trajectory when a glass slips off the counter. Your brain just instinctively reacts. Well, by processing enormous amounts of movement data, AI is giving robots that exact same split-second instinctive reaction capability.
So, you might be wondering, how exactly does an AI build up that kind of physical instinct? Well, it's through millions of simulated attempts. Long before a humanoid robot ever takes a physical step in the real world, it refines its balance and coordination in a virtual environment. It tries to walk, falls down, learns from the failure, and tries again. It iterates through this process millions of times. It's rapidly gaining what is essentially a lifetime of experience in just a matter of hours, entirely within a simulation.
And because of those millions of simulated attempts, we are seeing an absolute explosion of new capabilities. Suddenly, without being explicitly programmed to do it, these robots can effortlessly navigate uneven ground. If they trip, they actually have the AI-trained instinct to recover their balance rather than just crashing straight to the floor. They can even dynamically adjust their grip, knowing the difference between holding an apple versus a heavy metal block. The AI just figures it out based on its vast training data. It's honestly mind-blowing.
As you can imagine, unlocking this kind of insane potential has set off a massive global competition. We have officially entered the corporate robotics race. With AI proving beyond a doubt that it can effectively teach robot movement, several powerful entities across the globe are pushing this technology forward at extraordinary speed. The race to commercialize these AI-driven humanoid robots is fiercely competitive. And let me tell you, the approaches being taken are as diverse as the players involved. This race to commercialize has created some super fascinating and totally diverse strategies. Take Figure AI, for example. They are testing right in the thick of the real world, having recently completed an 11-month pilot on a highly chaotic BMW factory floor. Then you've got Tesla, who is taking a totally different route. They are reusing the AI architecture from their self-driving cars and directly applying that driving data to the physical challenge of humanoid movement. Meanwhile, companies in China are leveraging heavy government industrial policy support to compete incredibly aggressively on both speed and price.
All right, but it is time for a bit of a reality check. If you've been online at all, you've been hit by a flood of these robots doing super smooth dances, perfectly folding laundry, or even sprinting across a warehouse floor. And while that is visually stunning for sure, it's absolutely vital to remember that these are often highly curated, very carefully produced promotional pieces. They are designed specifically to generate excitement and, well, funding.
Because here's the catch. When independent trackers compared this promotional footage strictly against published operational data, a very different picture emerged. By completely ignoring the marketing videos, just tuning all of that out, and looking only at real-world deployment evidence, they found a massive gap between the viral hype and the actual reality of the industry. Evaluating performance based purely on objective operational data reveals a really stark contrast to what the marketing teams actually want us to see.
Which leaves us with a pretty uncomfortable question, and it's one you should absolutely ask yourself the next time a flashy robotics video pops into your feed. How many of the robots you just watched were actually working unsupervised, and how many were simply performing for the camera? It's a critical distinction to keep in mind as AI continues to revolutionize exactly how machines learn to move. Thanks so much for joining me for this explainer. I'll see you next time.
This is the dawn of ingenuity and robotic precision converge.
Welcome to this explainer. Today, we're skipping right past those sensational viral videos of backflipping robots to uncover the messy, totally fascinating reality of how these machines are actually integrating into our workforce today. We're going to look strictly at the facts to see how robots change our work and what this transition really means for the future of human labor. Let's dive in. Section 1. Leaving the demonstration stage, from the lab to the floor. You know, humanoid robots are no longer just confined to highly controlled tech demos. Instead of doing gymnastics on a stage, they are out in the wild right now. They are being rigorously tested inside major automotive plants, busy warehouses, and massive logistics centers. They are literally entering the exact environments that form the backbone of our global supply chain. But let's talk about the gritty reality of their current jobs. They're definitely not running entire facilities yet. Right now, they're handling highly specific, totally mundane tasks. We're talking about things like sorting parts, routing cables, and just moving components from point A to point B. This is really that critical first step in how robots change our work, starting from the ground up. Section 2. Hype versus hard reality. Behind these sensational headlines. Because the reality on the factory floor, it is way messier than what your daily news feed suggests. When investigators actually went in and checked the production numbers, those widespread claims you see about tens of thousands of deployed humanoid units just completely fall apart. If you read the actual company filings, you'll see that even the most advanced programs remain strictly in a supervised experimental phase. They are far, far from operating fully autonomously. And honestly, it gets even more fascinating when you look at the source of all this noise. Some of the most frequently repeated statistics about mass deployment, they don't even originate from the robotics companies they're supposedly describing. The internet's echo chamber just has this massive tendency to inflate the reality of how quickly these machines are changing our work. So, what is the actual reality on the ground? Well, rather than some story of instant autonomous success, we're seeing steady but very uneven progress. The integration of robots into the workforce is actually filled with revised timelines, unexpected delays, and quiet corrections that are happening entirely behind the scenes. It's a slow grind, you know, not an overnight takeover. Section 3. The real challenges ahead. Hurdles on the factory floor.
Now, you might be asking yourself the biggest question of all. If they're already out there on the factory floors, have they replaced us yet? And based on all the evidence, absolutely not. We are nowhere near a wholesale replacement of the human workforce.
Before a massive shift like that can even be considered, there are some monumental hurdles still in the way. First off, costs. They're still way, way higher than the tens of thousands of dollars companies eventually hope to charge. Then you've got major safety and reliability concerns. I mean, think about machines operating in unpredictable, dynamic human environments. And lastly, the massive societal question of how human labor actually adapts to this technology remains completely unresolved.
Section 4. Building a new workforce. The unmistakable trajectory.
Even with those hurdles, the speed of this evolution is just staggering. I mean, think about it. Just a few years ago, a humanoid robot taking a single, clumsy, unaided step was massive headline news. But today, they're physically working alongside humans on real production lines. They are learning, adapting, and actively participating in the supply chain.
Through all of this messy, uneven progress, we're watching them slowly but surely close the gap between science fiction and our daily reality. And the way robots change our work isn't going to happen in a single dramatic moment. It's happening right now through a million small, quiet adjustments on factory floors all around the world. So the biggest lesson to take away from this explainer isn't that robots have already replaced us. The real takeaway is that the foundation for a completely new kind of workforce is being constructed right now. It's happening quietly, mostly out of sight, just one careful step at a time.
It perfectly captures the nature of technological shifts. History shows us over and over again that by the time you actually notice a revolution has happened, it's usually already well underway. And that groundwork, it's being laid today in those warehouses and logistics centers.
Which leaves us with one vital question to think about as these robots continue to learn, adapt, and scale up, as the foundation for an entirely different kind of labor is poured. Are you ready to work alongside the new workforce? Thank you so much for joining me for this explainer. I really hope it gave you a grounded view of how robots are truly changing our work today.